Now we are going to see about the question given from GATE 2011 from Signals and System. So given that the trigonometric Fourier series of an even function does not have the following terms, that is DC term, cosine term, sine term, and odd harmonic terms. See here, the output out of the given four options is sine terms. Now we'll see. Coming to the solution, we know that the trigonometric Fourier series of a function f of t having the mathematical expression a naught plus summation n equals to 1 to infinity a n cos n omega naught t plus b n sin n omega naught t. So here a naught equals to 1 by t naught integral t naught f of t dt, and a n equals to 2 by t naught integral over the limit 0 to t naught f of t cos n omega naught t dt, and bn equals to 2 by t naught integral limits over 0 to t naught f of t sin n omega naught t dt. So here, given that the function f of t, f of t is even, nothing but f of minus t equals to f of t. So the given function f of t is even here, f of t is even, then we know that the integral of the even function is always having some finite value, always have some finite value. That's why here a naught is called the DC value, DC value, DC term. Then a naught getting some finite value is nothing but we have the DC term. We have the DC term in the trigonometric Fourier series if the function is even. So coming to the an here, so here we can observe that f of t is even. We know that cos theta, cosine terms are always even terms, even function. The multiplication of even and even becomes even only. So the integral of some even function again becomes some finite value. That's we already know. So the trigonometric Fourier series contains, here you can observe, this is an is the quotient related to cosine terms. So we'll have the cosine terms in the trigonometric Fourier series. So coming to the bn, so here integral f of t sin n omega naught t dt. Here f of t is the even function, and sine, we know that cosine terms are odd functions. So the multiplication of even and odd becomes odd function only. We know that the integral over odd functions is always equals to 0. So the bn terms becomes 0 here. Bn is nothing but you can observe that is the coefficient of the sine term. So the bn becomes 0 is nothing but there is no sine term in the trigonometric Fourier series. So out of the given options, we have the DC term, we have the cosine term, And coming to the odd harmonics is nothing but the values of cosine terms we can observe. That is, the cosine term contains omega naught, 3 omega naught, 5 omega naught, like that. Those are called the odd harmonic terms. So we have the odd harmonic terms also in the trigonometric Fourier series when f of t is even. So we have, out of the given options, we have only the thing bn equals to 0. Bn equals to 0, nothing but the sine term. There is no sine terms in the trigonometric Fourier series if the function is even. That is the solution.